In this today's lessons, I will show you how to solve rational equations and how to find the whole. Example number one. We have learned before how we solve proportional equations. For example, you would have 1 over x equal to, let's say, 5 over 20. So how do we solve for this rational proportion equations? Is by cross multiply. Okay, so we cross multiply. So we multiply 20 and 1, so we cross this over equal to 5 times x. And then we're going to divide it by 5. Divide everything by 5, so x equal to 4. So the rational solving rational equations exactly the same way as you solve the proportion equations. So you're going to cross multiply and then you solve for x. So before we solve any equation, any rational equations, or any time that you're dealing with rational equation, you need to find the restrictions or you need to find what we call the domain. So the domain for this will be x minus 2 not equal to 0. We do not want the 0 in the denominator. Then x is not equal to 2. So we cannot have x equal to 2. All right, so here we can cross multiply this. I know the examples I already did for you right here, but let's cross multiply this and we know what we're talking about. So we're going to cross, so keep the um the group inside the bracket when you cross multiplied it. Okay, so 18, I'm going to keep x minus 2 in the bracket and everything else in the bracket. So now I'm going to cross out the x minus 2 because they the same factor, same terms. When you multiply, you can cancel it. So you can cancel it. You're going to have 9x equal to 18. You divide by 9 on both sides, x equal to 2. So you have x equal to 2, but and then what happened here? At the beginning, you say x cannot be equal to 2, but at the end, you say x equal to 2. But you should be take that values of x equal to 2 away, then this one has no solutions. Because you have restrictions values that x equal to 2 cannot be a solution to these equations. So example number 2, I did it for you. So I don't want to keep repeating that. You can look at that. That's solving an equation with a couple steps. So let me start with doing this one over here to show you. So first, before you do anything, write the domain. So x plus 3 cannot be equal to 0. Turn out to be x cannot be equal to a negative 3. So here we can cross the x plus 3 on the bottom, but we go ahead and cross multiply first to see, what we can do. So we're going to keep the 5x minus 12 in the bracket, and then we're going to multiply x plus 3, keep it in the bracket as well, and 9x, and then x plus 3. So now we need to cross out the x plus 3. We're going to have 5x minus 12 equal to 9x. We don't want to divide by 9 yet here. We need to group all the x together on one side of the equations. If you notice that I try to always try to keep the equal size like, straight down, okay? So you want to trying to keep the equal size straight down. Then I'm going to minus 5x from here. Okay, and minus 5x from there, so that's 5x is gone. Negative 12 equal to 4x. Then I'm going to divide it by 4. So x equal to negative 3. So what's going on here? So no solutions. We cannot have x equal negative 3. Alright, let's do this one over here. So first, we need to find the domain. There are two denominators, so you have to find the domain for both. So first we're going to find the domain for 2x plus 1 cannot be equal to 0. Then 2x cannot be equal to a negative 1. Divide both sides by 2. It cannot be equal to negative 1 half. So that's one. And then we're going to find another denominator. It cannot be equal to a 0. Then same thing, so x cannot be negative 3 over 4. So those are the two x's that restrictions. You cannot have those two x's. After you solve it, you need to cross out the solutions if it's equal to negative 1 over 2 or negative 3 over 4. So now I'm going to cross multiply. Again, keep everything in the bracket when you multiply. Very, very important, or you just going to get the whole problem wrong. So I keep everything in the bracket. Now I'm gonna use a distributive, or I'm just gonna use on the scrap paper. You can use the box method if you like, but here I'm just gonna use the distributive bracket, the property. Distributive means you multiply it like this. Okay, so it'll be 12x plus 9 equal 10x plus 5. Then here I'm going to keep the biggest x where it is, and then I'm going to move or take away the smaller x. So I'm going to minus 10x, I'm going to have 2x equal to negative 5, negative 4 over here. Then x equal to negative 4 divided by 2, which is negative 2. So then you're going to compare with the domain. So compare, you want to compare with the domain. So the negative 2 is not one of the two values in the domain, then the solutions is accepted, so be x equal to negative 2. So I want to do those two examples for you there. That's how to solve an equations. So let's move on to these problems. Okay. So number 9, I give you the hint. So for this one over here, you just have to figure it out that the proportions of each person's um, belong to that person, then you're going to set up the rational equations. So you have one painter here. There's two painters, by the way. So one painter can paint the entire house in 12 hours. So you can see 12 right here. So the first painter paints the house in 12 hours. And then there's a second one. See, the second one can paint the house in 8 hours. So you write it down. What do you need to, and then you're going to set up how long would it take for two painters together to paint the house. So this is the first painter. You're going to have 1 over 12. That's the first person. And then for the second person, it's going to be he paint one house in 8 hours. Is always going to be equal 1 over x. So we figured out how many hours. So how do we do this? We cannot cross multiply yet until we have a single rational. Right now we have a rational and another rational. We need to combine those two first. We need to combine first. So how do we combine this? We can it's easy to find this by just simply adding using um, the fractions skill, adding skill. So the common denominator, we call the greatest common factor, is 24. Why? 24 divided by 2, 24 divided by 3. Okay, so the common denominator is 24. Okay, so I'm going to do 12 times 2, and then I'm going to multiply 1 and 2. Over here, I have 8 times 3, then I'm going to have 8, 1 times 3 over here. I'm going to keep the right hand side 1 over x, and now this is going to give me 1 over 22 over 24 plus 3 over 24 equal 1 over x. Then this is going to give me, I need more space, so that's why I'm writing this a little bit smaller. So be 5 over 24 over 1 over x. Now we're going to cross multiply this. So 5 over x equal 1 times 24 equal 24. Then x equal to 24 divided by 5. If you divide this, you're going to get 4.8 hours. So what does that mean? This is the numbers of hours they do together. If they work together. Okay. So if they work together. So that means in 4.8 hours, if those two painters working together, they will finish the house. I'm going to help you to do the next one. So this is the first person's. He can fill a pool in 2 hours. So you're gonna write down 1/2. And then the second 5 hours, a pie, not the person's. So like the water hose. So you can do 1/5 for the second one. It's over here. When both pie are open, how long will it take to fill out the pool? So you can write down 1/x. And then you're gonna solve an equation just like you did over here. So you need to try that on your own. What about this? Number 11, the Brad can tile a room in 4 hours. If Brad and Jeb work together, they can tile the room in 3. How long does it take Jeb to tile the room walking along? So let's just write it down. So for Brad, it's going to be 1/4. So again, this is Brad. And then what about Jeff? So Jeff is over here. He can tie. They can. We don't know how long for Jeff to tile the room. So we're gonna reduce 1/x. And then if they work together, they can finish the room in 3 hours. So we're gonna have 1/3. So now we need to solve this equation. First, we need to separate the x and the number on the opposite side of the equal side, and then we solve for x. So we keep the 1/x here. We're going to take away the 1, so we're going to minus 1/4 is over here, just like that. So then we're going to have 1/3 minus 1/4. Okay, so I'm just going to write down what I did over here. That's all. So now what I do here, the common denominator is 12. So we'll keep the minus, and then we're going to keep it like this. So it'll be 4/3, 4/12. So 3 times 4, I was going to write it, but you can do it. You want to be more clear. I'm going to go ahead and write it down. So it'll be 3 times 4, and over here, 4 times 3, then I'm going to do 1 times 3 over here like that. I might did too fast, but right now, you should be know how to add and subtract and multiply fractions. We learned this for a long time ago. So it's equal to 1/x is here still. The common denominator is 12. We're going to have 4 minus 3, which is 1/12. Now we're going to cross multiply this. So be 1 times 12. 1 times 12 equal to 1 times x. So x equal to 12. You take Jeff. So take Jeff 12 hours to finish the one room. To tie one room. So he's a little bit slower than Bragg. Alright, I'm moving on. I'm going to show you how to find the whole. So now we have the rational functions. Now let's just find the whole um, by factor this first. So here I'm going to factor this. On the bottom, be x plus 6, x plus 3. 3 times 6, 18. 3 plus 6 equal to 9. I'm going to do exactly the same thing to the top. So be x there. And now 2 number times negative 15, when you add in negative 2, so be negative 5 and positive 3. So negative 5 times 3, negative 15. Negative 5 plus 3, negative 2. So now to find the whole. Again, I'm just going to show you how to find the whole. To find the asymptotes, you have another video. I'll show you how to do that. So we're going to cross out the x plus 3. So the whole is x plus 3 equal to 0. So be x equal to negative 3. So finding the whole is if you can cancel the factor. Again, if you can cancel, if you can cancel the factor, then you have the whole. Then you will have the whole. So remember, if you can cancel the factor, then you will have the whole. So quickly to find the vertical asymptotes for this one. So you're going to make x plus 6 equal to 0, and then you're going to have x plus 3 equal to 0, then x equal to negative 6, x equal to negative 3. So, but now the whole is over here, and the vertical asymptote is there. So this would turn into the whole, and this still going to be the vertical asymptote. So instead of two vertical asymptotes, one of the vertical asymptote have turned is to be the whole.